So quick review of what we did the other day in science. A mixture is any combination of two things. It can be two solids, two liquids, two gases. It could be a solid and a gas, a solid and a liquid and a gas, whatever. Okay, as long as you have at least two. You can have 10 things, but if you combine them together and they stay the same thing, okay, it's a mixture. For example, we talked about paper clips and push pins and rubber bands. You put them all together, they stay the same thing. They're still rubber bands and they're still push pins and they're still paper clips. They don't change. Okay? Then we said, how can we start separating them? And we talked about the three ways you can separate them by hand, okay? By size, by shape, and by color. That's all by hand. Okay, I can move the colors differently, I can move shapes here, but either way you're doing it all by hand. Then we got into some special, unique ways that you could separate some things. Okay, one was by the magnetic attraction. You put a magnet near it, it'll pick up the things that are magnetic, okay, that are metal. If it's not magnetic, could you use this with rubber bands and pencils? Is that going to work? No. Okay, so then we got into some of the 5th grade things that we haven't really seen before, okay, and some of the fancy words. One is called sieving. It's called sifting. We call it sifting down here in the South. All right, you've done this. You go and take the shells and the sand at the beach and you put it in a little sifter and all the sand falls out, the shells stay on the top. Okay, the other one is filtration. Filtration is using a filter, a coffee filter. That's like the #1 thing. It will separate solids from liquids. The liquid falls through, solid stays in it. And then the last two went together, flotation and sedimentation. You add water to it. Some things will float, some things will settle or become sediment at the very bottom. Okay, so today we are going to be talking about dissolving. What does it mean to be dissolved? What does it mean if you're going to dissolve something?
It takes salt and water.
Okay, that's an example, okay? But what does the actual dissolving definition, what does that mean?
Whatever you put into it, like a liquid or something, it like moves and it just...
Okay, it's when you put something into a liquid and it completely disappears. Basically, it becomes part of the liquid, all right? So the definition of dissolving is forming a mixture of a liquid and a solid, or it can be a solid or a gas or water or another liquid. But this is where the solid mix is so small that you cannot see it differently than the liquid. Okay, so if I were to pour something or put something into a liquid and it dissolved, it broke down so small that I can't see it with my naked eye. I'd have to use a microscope or something like that to see the little tiny particles that broke down. Okay, you cannot see a difference between the liquid and that solid you put in there. It basically disappears. That's kind of what we say. If you put something in the liquid and it disappears, it's really been dissolved. There are some things that you'll put in liquid and it just doesn't change. You could see it. You could see that thing in there and it does not change. For example, if you took a toy car and you threw it in a bucket of water, will that toy car just break down into nothing and all of a sudden it's gone and disappeared? No. You could still see the toy car. You could still see the water. It's nothing different. However, there are some things, for example, Kool-Aid. You guys have all done this. You pour the Kool-Aid powder, which is a solid, into a drink, into water, and all of a sudden it disappears. Do you see all that powder everywhere? Is it on the bottom? No. It has mixed in with the water so well you can't see a difference between the water and that little bit of powder. Yeah, the color changes some, but it's completely different. You don't see, or it's completely disappeared. You don't see a bunch of little pieces of powder floating around in there, right? Because it's what we called dissolved. Another one, Addie mentioned, salt water. Okay, you've all been to the beach. You've had water in your hands or whatever. Have you ever looked in your hands and see, oh look, there's a bunch of floating salts all in this water? No, because that salt has dissolved so much, it has broken down so small, you cannot see a difference between water and the salt. Okay, So salt water is another example of this. If I were to put something in a liquid, there are 3 ways to make it dissolve faster. Can you tell me, or can you think of 3 ways to make something dissolve faster? You guys are all here in the South. You've all had some good sweet tea. What do you do to make that sugar or the tea bags or whatever? What do you do to make it go dissolve faster, disappear quicker? What's one way? Stir it up, right. One way is to stir it up. What's the other thing that you do when making good old sweet tea? You stir up the sugar, it makes it go faster. What else? You gotta make it hot, right? Boiled water. You guys are all from the South, you know that nobody can take cold tea and add sugar to it and stir it up and it's gonna dissolve very fast, okay? We've all done that. You go to the restaurant and you ask for sweet tea and they say, oh, we have unsweet tea, but you can add sugar. And you put the sugar in that nice cold iced tea and you stir it up and you stir it up and you stir it up, and guess what? That sugar never disappears because it's too cold. What's another way?
If you have the little juice packets, you can shake it up in the water.
Okay, that's shaking it and stirring it. That's the same thing. You're moving it up. Anybody else got another way?
Heat it up.
We said heating. Make it hotter, shake it or stir it. We got those 2. What's another way to make something go faster? Dissolve faster. You make the surface area smaller. What does that mean? You break it up, okay? I know here in this, you guys have not really ever used sugar cubes, right? Some of you may have seen it, but you don't really use it, right? If you put a sugar cube in your soda, or I mean in your iced tea or something, and you want to stir it up, it's going to take a very long time. That's why you use little pieces of sugar. You take a sugar cube, you smash it up, and you stir that up, it's going to go a lot faster, okay? So when it comes to dissolving things, what's going to make it go faster? Heat it up. The hotter it is, the faster it will dissolve. You can also stir it up. We know that if you put a bunch of sugar or salt in water and you just let it sit there, eventually it'll dissolve. But you want it to go faster, stir it up a little bit and it's gone. And finally, if you want it to go even faster, you break it up. That's why if you ever see mom or dad making sweet tea, what do? They heat it up. They use the little sugar, right? Sugar packets or a cup of sugar, and they stir it up all in one. They do all 3 of those all in one. Okay? Let me show you a couple different kind of videos that kind of show this and prove this. All right, so the first one, this is dissolving in water. They call it diffusion, but we're going to call it basically it's mixing up to become dissolved. All right, so here I'm going to kind of fast forward it. They're basically taking 3 beakers of water, okay? And those 3 beakers of water, one is going to be cold, one is going to be hot, and one is going to be normal temperature, okay? So again, they're going to take one, put it in an ice bath, going to make it cold, okay? So the first one is the cold one. Or actually, I guess that's number 3. Number 3 is going to be the coldest one. Number 1 is going to be the hot one. So 1 is hot, 3 is cold. What do you think 2 is going to be? This is called the control. This is the one they're not going to change. This is room temperature, okay? So again, they turn it on, they get it hot, they record the temperatures, and here we go. Fast forwarding it. So again, number 1 is hot, number 2 is normal, room temperature, that's the control, and number 3 is cold. So now they're going to put 3 drops of food coloring in there. And if you notice, this food coloring starts to dissolve, okay? And this one starts to dissolve. And this one will start to dissolve. But watch the difference. What do you notice?
3 is slowest.
3 is the slowest, right?
1 is the fastest.
1 is the fastest. Why?
Because it's hot.
The hotter it is, the faster it's going to dissolve. It's just like you guys get. If it's a really, really cold day, how many of you want to go outside and just run around and play all day? No. Okay. If it's a nice warm day outside, what do? That's when you want to go play, right? Okay. Now, if it's way too hot, you don't want to. I get that. But here you go. This proves that the temperature affects the dissolving rate. Really hot, really fast. Not so hot. It's still going faster than the really cold. Okay? So that is temperature. This one is all right, so now the kid is, they're going to take tablets, all right? And they're going to take these effervescent tablets or Alka-Seltzer tablets, if you will, and they're going to put them in water. And they're going to do one as a regular whole tablet, and the other one is going to be broken up into smaller pieces, okay? So, let's fast forward. All right, so here we go. So here he goes. He's going to put one whole tablet in there. And so they're going to time how long this takes to dissolve. One whole tablet of Alka-Seltzer dissolving. And it's taken a little while, and look at it, it's still dissolving and still dissolving.
Is that the stuff that like makes it fizzy?
And that's the stuff that you take when you have an upset stomach. It's a medicine. Okay? So if you notice, look at it, it's still solid. It's still fizzing, it's still dissolving. And so finally, he says stop, and it takes a long time. Now, he's going to break it up and see a difference. All right, so here he's taken and broke it in half, okay, and he puts 2 of them in there. And so you can kind of see, again, if we were timing this, he's timing it. I don't have the sound playing because I really didn't want to listen to him there. But if you notice, it's pretty much almost done already. So by breaking it up, it went like twice as fast, okay? And it's still going a little bit, but for the most part, it's almost gone, right? So whole tablet versus broken tablet, which one went faster? The broken tablet. What happens if you broke it up a lot more? Well, let's find out. So now he has 3 of them. So if you take those 3, he drops all 3 in there. If we were timing this, if you compared that, went a lot faster. Let's see. This one has 4 pieces, and so on and so on. Okay, so you saw that the more you broke it up, the faster it would go. One last thing I thought that was pretty cool is, my question to you is can everything dissolve in water? What are some things that can dissolve in water? I want you to think about that because you're going to see that tomorrow. It's going to be part of your lab. But there's some things that does not dissolve in water. There are some things that might shock you. There are some things that you might be surprised can dissolve. There are some things you might be surprised that cannot be dissolved. This is an example of one of these that may actually kind of shock you. Something is playing that shouldn't be playing.
over this
Yeah,
weekend?
it's a girl, so.
Oh, excuse
Looks
me.
like a girl you
So
used to
sorry.
date years ago, so she came back. It's Herman, I don't know if it's a her or a man, so I have
Oh,
no
I see.
idea, yeah, so that's how it works. And we gotta put some stuff into her little brain, all right? And you can't put things into her brain with a hat on, so that's why kids can't wear hats in schools, or so teachers will tell you. So we take her little hat off, always safe, so she's always safe. Here's what we need elements of these kinds of things, so I just put them on the board, so it's an element of wonder. So here's an element of wonder, and we just put a little bit of wonder down into our head like this. Is that kind of fun? So a little wonder. What do you have, Mark? You have
Pretty
risk.
good.
Is that
I
good?
have
risk.
risk.
Yes, absolutely. A little risk goes down inside the head like this. And by this time, the kids are going, "Wow,
Look
how
at
is
that."
it? And why does the room smell like acetone?" Right? I'm wondering, is that kind of fun? And finally, what do we have here? We have whatever message you want. Isn't that kind of fun? We have teachers and team builders and people like that. We're using
Oh,
a science
kids
demonstration.
would just
Isn't
love
that
that.
great?
Oh, that's
So
terrific.
isn't this fun? Anything you want to put in the person's head.
That
you
is
can
so
down inside.
fun.
Now here's the secret, so down inside, so now I told our camera people, don't reveal it early on, so look at this. This is the secret, so you see the hole in the head,
Sure
all right?
enough.
And so the secret is here, and believe it or not, the secret is acetone. You have the secret.
Explain to me what just happened.
The acetone dissolved the foam.
So you had styrofoam, and that styrofoam is being dissolved in the acetone. So it wasn't a water, but there was a liquid. We put something in there, and it becomes dissolved. And you can see that liquid is pretty much clear. You can't see a difference between the two.